So again, we have another very good session prepared for you guys. And the next presenter is JJ, who happens to be in Taiwan today. And he's with eLux Incorporation. And he'll be telling us about a very, hang on, he'll be telling us about a very interesting, simple, fluidic self-assembly mass transfer for micro-LED displays. So the stage is yours. And JJ, I wish you good luck. And at the end, we'll be asking you lots of questions. So
Okay,
enjoy your
thank you.
presentation.
Thank you. Hello, everyone. I'm JJ, and my presentation is Fluidic assembly of micro-LED. So why do we want to use the Fluidic assembly? The first reason is low-cost manufacturing. Using most of people using pick and place, laser transfer, or stem transfer. They are all sequential process. So for a large micro-LED TV, you will need tens or hundreds of hours to complete. For FSA, it is a parallel process. So we can do the assembly simultaneously on a big panel, even Gen 6 or even larger glass. Secondly, in terms of the performance, FSA, we can produce a Mura-free display. So all other technology will have a stem Mura. And to remove that stem Mura, you need to do the renderization of the micro LED. And for the pick and place or laser transfer, if people doing the renderization, display cost will increase by 30% about. FSA basically naturally makes the micro LED, so there's no stem Mura at all. And the some image below monochrome or color image, you can see the stem Mura on the right hand side, and very uniform display on the left hand side. And in fact, we use the LED with a wavelength range of about 10 nanometer without any Mura. On the right hand side, the wavelength range is 4 nanometer, but still see the Mura. Nice page. Okay, let's compare the different mass transfer methods. The first one is stem transfer, laser transfer. The second one, on the last two is FSA, either directly on the TFT glass or it's on the carrier. From the carrier, then we transfer to the TFT glass later. For stem Mura, I just show you the pick and place and the laser transfer will have a stem Mura. And so you have to have a very good MOCVD tool to make a very uniform architecture. And for FSA, those MOCVD requirement can be relaxed. Second is panel-to-panel Mura. For the stem transfer and laser transfer, if you do the very careful binding and sorting, you can minimize the Mura. For FSA, basically you just mix all the LED together, then you don't see the Mura on the panel-to-panel level. Tool precision, because the stem transfer or laser transfer involve a lot of mechanical control. So you need a very, very good alignment. For FSA, it's a self-aligned process. The tool is very simple. Again, the panel size, we can go very big because there's no alignment issue. And the other thing is non-good die or non-good LED transfer, meaning that when we do the transfer, we select the good LED. For FSA, we can remove the bad LED before before the fluidic assembly.